There it is. And let's move into chapter 2, architectural thinking. This is a really cool chapter because it does touch into like the not the responsibilities, but like the importance of having a technical breadth. There's an interesting frozen caveman anti-pattern that we're going to discuss, and this part is especially cool with analyzing trade-offs, which we'll see like an auction system with a topic, an auction system using queues, and how as an architect we can analyze the trade-offs between these two and which one should we pick. And yeah, and then at the end there's like the importance of balancing architecture and hands-on coding. So yeah, let's just dive in. This is chapter 2 of the Fundamentals of Software Architecture book. It is titled Architectural Thinking, and the architectural thinking is seeing things differently from a developer's perspective. It's not just thinking about the architecture or like thinking about how am I going to connect these two services or these multiple services, or are we going serverless or VPS, etc. It's not just thinking about the structure. There's more to it. So there are like 4 aspects of thinking like an architect. First is understanding the difference between architecture and design. This is really important, and there's like a whole section dedicated to it, like architecture versus design. So we'll talk about that. Second is having a wide breadth of technical knowledge while still maintaining a certain level depth. And that is the next section right here. Third one is analyzing, understanding, and reconciling trade-offs between solutions and technologies. Again, with the analyzing trade-off section at the bottom. And the fourth one is on understanding the importance of business drivers and how they translate to architectural concerns. There wasn't too much in this section. As you can see, it's like a single paragraph. But yeah, we are gonna go through each of these. All right, so understanding the difference between architecture and design, or the architecture versus design. Thinking like an architect is knowing the difference between architecture and design. Traditionally, an architect's responsibility included analyzing business requirements and translating them into architectural characteristics, deciding architectural patterns and styles, or which that will be used. This can be improved as a sentence, and creating components or the building blocks of the system. And these artifacts were then handed off to the development team. What this basically means is the architect, has a meeting with the stakeholders. They learn about the business domain of the application or the business itself. They learn about the gotchas. They learn about the facts and the environment, etc. And having the business domain in mind, having the nature of things within that application, like for example the type of the audience, etc., etc. The main idea is that the architect's responsibility is to get those business requirements and translate them to architectural characteristics, which we touched upon in the previous episode. If you haven't watched that, go to my YouTube channel and you'll see a video of the first chapter. Those are the ilities like scalability, elasticity, what else was there? Security. There's like a whole bunch of them. But yeah, that's basically the architect's responsibility. And traditionally, this has been the setup in companies. So there's like the architect here. The architect produces the characteristics, the style, architectural style that is going to be used, the component structure, and all of these were handed off to the developer. So the developer can, or developers, can produce class designs, the user interface, the source code, basically get the artifacts from the architect and produce the application or build the application, right? So this is architecture, this is design. And the architecture versus design, or especially the traditional responsibility model that divides the architecture from design is broken. It doesn't work. And the issue is the unidirectional arrow that passes through these both virtual and physical barriers. That's what's wrong with this setup, because it separates the architect from the developer. For example, decisions that the architect makes sometimes never make it to the development team, right? Especially if it's just turn on do not disturb so we don't have like notifications and stuff. There we go. Yeah, sometimes never make it to the development team. For example, decisions that were made a bit later on, because of that barrier, they might never make it to the development team, and also vice versa. Decisions that the development team makes that affect the architecture never make it back to the architect, right? For example, the developers might make a decision: we can't really use this library or this or implement this approach because X, Y, and Z. And they're just not going to, they're not going to do it. They're going to do ABC instead. But ABC changes things, right? And it's important that that decision goes back to the architect so that the architect can analyze the trade-offs, which we'll learn about in the third section here, and make the needed changes to the overall architecture to support ABC instead of XYZ, right? And this barrier between these two is what prevents that communication. So yeah, in order to make architecture work, we need to break down the barriers. The architect and the developer must be on the same team. This also allows the architect to provide mentoring and coaching to the developers on the team. Yeah, this has been like the traditional responsibility model. You have the architect or the chief architect or the lead architect and a bunch of developers. And these two work or used to work in silos. That has been proven that it's not good, right? Now we have the agile methodology of running things. We have sprints and short deliverables. We ship often, and that makes, that allows us to iterate on our solutions and also just, experiment more and often. And having this barrier just doesn't work, right? So yeah, where does architecture end and design start? It doesn't, right? This needs to be broken down if it's not in certain teams. And yeah, both architecture and design, or in this case, it's development, but yeah, they coexist in parallel within the life cycle of the software project and must be kept in synchronization. The life cycle of the software project means it's not about the architect goes in, designs the whole thing, and then gets out, and then the developers go in and take the designs and work while the architect is someplace else. During the life cycle of the software project, both architects and developers work together in cohesion on the same project at the same time. So that's what this section is trying to tell us. Right, so that was the first aspect, right? Architects and developers working together. The second one is the architects having a decent technical breadth and why that is important. So a developer focuses on acquiring and maintaining technical depth, while an architect focuses on technical breadth. It's crucial to have a significant amount of breadth in order to think like an architect. And we can categorize all the knowledge of the human into three sections. The stuff that we know is at the top. The stuff we know that we don't know. For example, I know Kubernetes exists, but I haven't worked with it, so I don't know Kubernetes. And there's also stuff we don't know that we don't know. And I can't talk about them because I don't know them, right? So this is the knowledge pyramid. The developer focuses on expanding this stuff they know. And this, the further down this is, the technical depth is, or the knowledge, the technical knowledge is deeper. But that's for the developer. For the architect, the most important parts are the first two. It is still important to maintain, all of that's actually here, but like the first two are the most important parts of the pyramid for the architect, especially making the stuff we know we don't know, thus the middle part, expand into the bottom part. The more the architect does that, the more technical breadth they have, and that's where the value comes from, right? Is having a broad technical understanding and knowing how to use it to solve a particular problem. Yes, the top and the middle. That's why it's wise for an aspiring architect as well. So for the architect, but also aspiring architects as well, people like you watching, to sacrifice some hard-won expertise to gain time to broaden their technological portfolio, right? So we are developers by, for starters, we focus on getting technical depth, but some developers decide to move into software architecture, into the architect role, and they need to sacrifice some time instead of focusing on depth to actually broaden their technological portfolio or the technologies that the concepts, etc. Of course, some expertise will remain, most likely the technologies that the architect enjoys working with. For example, if you are passionate about front-end and CSS, those things will remain. You will remain an expert in those things because you will practice them. You like that. You like building UIs. But you're also focusing on, on broadening your technical portfolio. But others will usefully atrophy. I like this phrasing here, usefully atrophy. You're going to let parts of your skills atrophy, but usefully in order to trade them for time so that you can gain more breadth, technical breadth. And transitioning to an architect role from a developer role means a shift in perspective, which many developers find difficult. And this causes two common dysfunctions. First, an architect tries to maintain expertise in wide variety of areas, succeeding in none of them. This means that the architect that used to be a developer is trying to remain just as good as developer, while also broaden their technical or to broaden their broaden their technological understanding. But this basically means they're gonna succeed in none of them, right? Because you can have to. The time is limited. And the second one is gaining having stale expertise, which means the mistaken sensation that your outdated information is still cutting edge. These are the two common dysfunctions or the two common situations that developers can find themselves in when shifting to the architect role. So be on the lookout. There's this interesting frozen caveman anti-pattern explained here, and that's basically a behavioral anti-pattern that describes an architect who always reverts back to their irrational concerns for every architecture. There's a situation, one of Neil's colleagues, Neil is one of the authors of this book, they worked on a centralized system, but each time they delivered a design, they asked, but what if we lose Italy? So several years before, a communication problem had prevented the HQ to communicate with the stores in Italy. And that caused great inconveniences. I think this is like softening the effect, like inconvenience. It's not inconvenience, it can be like business critical, not being able to communicate to your franchises in Italy. But yeah, because of that, the architect can, become obsessed with this particular architectural characteristic, which is availability, right? Or scalability. I don't know in that case what the characteristic has been, but yeah. This anti-pattern manifests in architects who have been burned, just like Neil's colleague, who have been burned in the past by either a bad decision or something unexpected, making them particularly cautious in the future. And that's why, even though they worked on a centralized system, there's no, for example, servers in Italy that communicates within their own network. So what if we use Italy? There's no more Italy, right? There is Italy, the country. The stores are there, but it's a centralized system, right? But because the colleague was burned in the past by that mistake, he keeps asking, but what if we lose Italy? That means his mind, I'm assuming that it's So his, I don't know why I started saying that, but yeah, that means Neil's colleague is focused on that characteristic, which might not be applicable in, in the current project, right? In that case, it's a centralized system. There's no Italy networks. Yeah, assessing the risk is important, but we should also be realistic. We should understand the difference between genuine and perceived technical risk. Thinking like an architect means overcoming these frozen caveman ideas, seeing other solutions, and asking more relevant questions. Another thing to be on the lookout. All right, let's get into the third part, analyzing trade-offs, which is one of the aspects of architectural thinking: understanding, analyzing, and reconciling trade-offs between solutions and technologies. Thinking like an architect is seeing trade-offs in every solution and analyzing them to determine which one is the best. There's a quote by Mark Richards, one of the authors: "Architecture is the stuff you can't Google." And I like this quote, really like this quote. Because, the most famous architectural answer to every question, it depends. Remember that from last episode? Yeah. So because everything, the answer to everything is it depends, that's why you can't really Google that, right? There's a possible solution, but it depends. Maybe in your case, it's not the solution. Everything in architecture is a trade-off. Hence the famous answer to everything, it depends. There's another quote by Neil Fort: "There are no right or wrong answers in architecture, only trade-offs." So we're going to see an example of an item auction system where someone places a bid for an item up for auction. The bid producer service generates a bid from the bidder and sends it to the bid capture, bid tracking, and bid analytics services, right? This is like a microservice situation, and we need to figure out the communication. There are two possible, or like the inters microservice communication. So there are two possible solutions: using topics like PubSub or queues, point to point. Which one should the architect use? So let's analyze the topic solution. Here's how it looks like. We have topic here. I don't know, Apache Kafka. The bid producer sends the item bid event to the Kafka topic, and now the bid capture, bid tracking, and bid analytics have subscribed to that topic, and they immediately get the event, right? That's how the communication happens in using a topic. Yeah, and so the pros are that the bid producer only requires a single connection to the topic, right? That's important. If a new service get added, like bid history, for example, we're not gonna need to change the existing system. We don't need to update bid producer. We just need to add the bid history here and subscribe it to that specific topic, and that's it, right? And the bid producer is more, this way it's more decoupled, and it doesn't know how the bid info is used. So the clear advantage of this architecture is architectural extensibility, right? We have a central topic system like Kafka. There are producers, there are consumers. In this case, the bid producer is a producer, and the three services on the right are all consumers, which they subscribe to the topic in order to get the events and the details, right? Now let's look at the queues. The queue system looks like this. There's a queue for each of the services or each of the consumers, let's say, and the bid producer needs to explicitly send the item bid to those queues in order to communicate to the capture, the tracking, and analytics services. If we compare the queue solution to the topics solution, the bid producer needs a separate connection to HQ. That means the bid producer, it just needs a separate connection. That's networking, that's latency, etc. And that's also three network requests to communicate one event. Adding a new service means creating a new queue and connecting to it. So it's not just about the service, it's also spinning up a whole new queue. And that means the bit producer is more coupled. It knows how the bit info is used because it explicitly sends the item bit to the services, to their queues. But that also means adding a new service will need to, in that case, we're gonna need to refactor the bit producer and include sending the item bit to it, right? So these are all like negative aspects of using queues. You might think, you know, let's just go with the topics. But thinking architecturally is also looking at the negatives of the given solution or the trade-offs. So let's look at the trade-offs for the topic solution. First, anyone can access the bidding data. And this is a huge issue with data access and security, right? In this case, the bid producer sends the bid to the topic or to the, I think it was called broker. Anyone can subscribe to the topic and get the data, right? The broker doesn't actually pick which, you know, which consumer can consume, I think. So out of the box, this can be a security issue. There can be a rogue service that can just subscribe and get all of the bids, right? But we don't want to send that data to that service. But in contrast, in the queues solution, the bid producer knows exactly where it sends the data and can alert, you know, when a rogue service tries to wiretap into it. So this is more secure. This is less secure, right? The contracts are homogeneous. The contracts are basically the shape of the data that the producer sends to the consumer. In the topic case, there's just one contract. It's the item bid and that's it, right? The bid capture, the bid tracking, and the bid analytics, all three services will receive the same data from the bid producer, and they need to make it work, right? Because this is not a specialized connection. It's just broadcasting. Here's an item bid. Who wants to, you know, the data? Who wants to get it? Be my guests. So the contracts are homogeneous. It sends out only one shape of data, forcing all the subscriber services to accept it or, you know, make use of it. But in the queues solution, just scroll it like this, the bid producer can fine-tune the bidding information per service because it explicitly sends them to each of the services. For example, to the bid capture, it can send one section of the data. To the bid tracking, it can send maybe the whole bid. The bid analytics, maybe it just needs the ID and the price. I don't know, whatever, you know, whatever is needed for the bid analytics. So in this case, we have, you know, better communication per service. And then third, the topic model does not support monitoring of the number of messages in the topic, and hence auto-scaling is harder to implement. Now, this is technology-specific trade-offs. Some messaging protocols do support programmatic load balancing and monitoring. There's a huge, I mean, not a huge, but there is a disclaimer that some topic implementations can support monitoring, but some don't. So there can be auto-scaling issues in this solution. In the queue solution, each queue can be monitored individually because there are separate queues, right? Hey, they can be monitoring individually, and we can apply programmatic load balancing to scale them automatically. So here's a little table of the advantages and disadvantages, for example, to the topic solution. But looking at the, like after analyzing the trade-offs, which is a better option? Again, it depends, right? The advantages of the topic solution is that it provides architectural extensibility, but it lacks security, and it has some data access concerns because of the the nature of the topic. Another advantage is that it decouples the services or the consumers from the producers. Anyone can just tap into the topic and receive the data, but The disadvantage is no heterogeneous contracts. Uh, it just sends out one data shape, and all of the services will either have to take it or leave it, basically. And there's also no monitoring and programmatic scalability in some of the cases, or some of the implementations that do not support monitoring. So yeah, everything has a trade-off. Thinking like an architect is analyzing these trade-offs and then asking which is more important, extensibility or security, right? And this is also important why business as an architect you need a good business domain knowledge, because if this is a banking application or a healthcare application, you would definitely prioritize security or extensibility. So if you're working on a application where the data or data access is, the data is sensitive, the data access is very strict, you would go with queues because you need to ensure security. If this is not, or if the application is not that type, if it's like I don't know, social media, just like tweeting 280 character tweets, no, not really full of sensitive information and stuff like that, the data is pretty much public, then go for extensibility because it's going to be better and the team is going to implement it much faster, right? So yeah, it always depends, the decision between the solutions always depend on the business drivers, the environment, the team, the knowledge of the development team. Are they skilled in Python? Are they skilled in JavaScript? It's not just the decision between these two, but like every architectural decision is based on these on these factors, basically. Understanding business drivers. Thinking like an architect is understanding business drivers and translating them into architecture characteristics. I just touched on that with the security and the banking and stuff. This requires the architect to have a certain level of understanding of the business domain and to have a healthy collaborative relationship with the business stakeholders. So basically, as an architect, you cannot allow yourself for the stakeholders to hate you or not to trust you, because it is important to to have a collaborative relationship. Why? Let's say you work. There was an interesting example, I think, further in the book. There was an interesting about a franchising restaurant, a restaurant franchise where the stores are all located on like the East Coast, and they need an app that will allow the people to order breakfasts, right? It's a breakfast place, a breakfast restaurant, and people can order breakfast from the application. And the business domain in this case includes where the audience or the users are. They're all on the East Coast. They're in California and Washington and Oregon and Portland, etc. They're on the West Coast. Did I say East Coast? Doesn't matter. They're on the West Coast, so that time zone, and that tells us something that when it comes to availability, when it comes to scalability, and also when it comes to elasticity, those three characteristics are defined just by knowing that the restaurant only has users on the West Coast. We don't need to support Europe. We don't need to support Asia. All of our servers need to be on the closer to the West Coast, right? Another thing, it's a breakfast place. It's not a dinner place, right? That means the majority of the traffic is going to come in the morning hours when breakfast is served. And because we know that all the users are on the West Coast, we can really pinpoint where or in what time frame we can anticipate the most traffic or the spikes of traffic, right? People go at I don't know, at the office at 9 a.m. At 9:15 they start ordering breakfasts. So at 9:15 you can expect a sudden surge of users. And if we're talking about elasticity, and you're working in AWS as an architect, you can say from like 8:30 until 11, increase the number of nodes or number of servers to 10. so that it can handle the if you're doing like EC2s, you can increase the number of instances to 10 so that the application or the platform can survive the surge, right? Can survive the spike, and then scale them down to like 2. That's another that's another decision or architectural characteristic that the architecture can make, knowing the business domain and the nature of the application that they're building. So that's what this means. And then in the end, we have balancing architecture and hands-on coding. And let me just take a sip of water. AF says, at work I use GCP, pops up a lot. Seems like it can be set up to work both as a topic and as a queue. Yeah, there are many solutions like that that can support both mechanisms, basically. The difference is how the topic is set up, of course. This is really good for the path I'm on. I keep getting interrupted from watching with recruiter calls also. All right, yeah. Balancing architecture and hands-on coding. Every architect should code and be able to maintain a certain level of technical depth. The first tip is to avoid the bottleneck trap. Let's say that you want to maintain, you should maintain technical depth and have an ongoing hands-on coding activities within while you're working on the project. But the first thing you should look out is to avoid the bottleneck trap. And that is when the architect takes ownership of critical code and becomes a bottleneck to the team. You're an architect and you have different responsibilities, but you still have you still have some time to do some coding. If you take ownership of critical code and you only work on that in your free time, you're gonna block the whole team. Like, the developers are going to catch up with you and like at the very beginning of the sprint, and they're gonna wait for you to finish working on the critical codes so that they can continue. That's a bottleneck. And this happens because the architect is not a full-time developer and can produce code with the same frequency as the developers can. To avoid this, the architect should delegate critical code to the others and focus on coding business functionalities that are 1 or 3 iterations or sprints down the road. So these can be features that are planned, but in like or nice to haves, not must haves, or like planned for a future sprint. The architect can work on them so that they don't become a bottleneck to the team. Another tip is to do frequent proof of concepts. And this is really important for an architect. This not only helps you write code, right? It's a POC, you're still writing code, but it also important because it allows you to test and validate the architecture decisions. And I think this is also a natural aspect, of working as an architect. You make a decision, but you need to validate that, right? You don't always have the knowledge and the confidence whether that's going to work or not. You might be missing some information or like some aspects, details of the technology. We discussed that the architects they have technical breadth, not depth. That means they're not experts at everything. That means they're missing a lot of details when it comes to specific technologies or frameworks or languages, right? Doing these proof of concepts will allow you to, as an architect, to fill up that void or that knowledge gap and to validate whether the decision that you're making is feasible, technically feasible or not. The architect should also strive to write the best production quality proof of concept codes they can. It's a proof of concept, it's a POC, but still they need to strive to write the best production quality, because oftentimes that POC code ends up in the actual source code. Like, I developed it just to see if we can achieve it with that way that I, as an architect, think. But the developers are like, well, you already have this working, so we're just gonna use this and build on top of it. And if this is rotten, the whole thing is gonna be rotten, right? So that's why it's important to focus on writing actual production quality code, even though it's a POC, because it can be the foundation for the future features that I'll, planned on top of it, and become a reference architecture or a guiding example, even worse, a guiding example that others will follow. If your POC code is smelly, usually architects have like a mentor or a coach responsibilities to the team. If this is written by the coach and I'm a developer, I'm just gonna follow, right? If smelly code is what code should be, or of what code is, then smelly code I will produce. So yeah, strive to write the best production quality POC code, even though it's a POC. Another tip is to tackle technical depth stories or architecture stories. These are usually low priority, so if the architect doesn't have time to finish them, it's not the end of the world. It's not going to impact the success of the product. We're talking about technical depth, which usually involves refactoring code, cleaning up, just refactoring. Another thing that the architect can focus on to maintain hands-on coding is fixing bugs. This is important. I mean, we know as developers that we don't want to fix bugs, we want to build features, right? Architects have a special benefit of focusing on bugs because they can identify, bugs will help identify where the issues are and where the weaknesses lie in the code base or potentially even the architecture, right? Some bugs are caused by the architecture itself or by the structure, right? And you made that decision. And the developers might not know that this is caused by the architecture, or they might know, but they don't know how to fix that because it's an architectural fix. It's not a source code fix, right? Or it's like a larger than just write some code and fix it. That's why it's important to, focus on fixing bugs because, they give more to the architect than they give to the developer. If you're a developer, bugs suck. But if you're an architect, they can show you some, more details that are of interest of you. Then the architect can also focus on creating simple command line tools like CLI tools and analyzers for the development team. Look for repetitive tasks that the team performs and automate the process. There's also mention of fitness functions in this case. And fitness functions are, I still don't know, I haven't reached that point in the book, but fitness functions are basically unit tests for the architecture. And I feel like those are going to be really cool. But yeah, you can focus on those. It's still coding, it's still writing code. But yeah. And the last tip is to do frequent code reviews. This allows the architect to ensure compliance with the architecture and also to seek out mentoring and coaching opportunities within the team. It's not really hands-on coding, right? It doesn't fulfill the hands-on coding aspect, the important aspect of hands-on coding, but it's still important because there's mentoring and coaching involved. And when developers make those decisions that affect the architecture and they tag you to the PR, you as an architect, you're going to notice that and you're going to talk about that within the same PR, right? So if there's an issue and of implementing something that you decided to be implemented, doing code reviews, you're going to catch it and you're going to talk to the development team about it, why can it be implemented and how you can make a compromise basically. So yeah, that's also like how you can, that's why it's important to balance architecture and hands-on coding, and like how you can do that. Just stay away from critical codes, leave that to the team, do like POCs, technical depth, do some refactoring, fix bugs, do some code reviews. For an architect, that's going to be enough, like hard skills in coding, And yeah, this is chapter 2, architectural thinking. If you have any questions,